Let's take a look at this problem. We got x minus 5y is equal to negative 9, and y is equal to 3x minus 1. And first we'll solve it via substitution, then we'll solve it on the calculator. Now, first step is solve one of the equations for one of the variables. I'll choose the second one. The reason why I choose it's already solved for y, so it makes that step so easy. Step 2, now plug this into your other equation and solve. So we got x minus 5y is equal to negative 9. So we got x minus 5. And up here we just said y is equal to 3x minus 1. So we're going to replace the y here with 3x minus 1. And now we want to solve. So I use the distributive property. Negative 5 times 3x is negative 15x. Negative 5 times negative 1 is a positive 5, equals negative 9. Combine together like terms. 1x minus 15x is negative 14x. And take the 5 over, and it becomes a negative 5. So that gives us negative 14x is equal to negative 9, negative 5 is negative 14. Divide both sides by negative 14. And we get x is equal to 1. Now step 3. We want to plug that back into the equation from step 1 and solve. Well, the equation from step 1 says y is equal to 3x minus 1. And we just said that x was equal to 1. So we'll put 1 in for the x. And solve it. 3 times 1 is 3, minus 1 is 2. So our answer will be 1, 2. Okay, now to do it on the calculator, we have to have all the variable terms on one side and the constant terms and numbers on the other side. My first equation is fine. X minus 5y is equal to negative 9. For my second equation, I'm going to take this 3x and move it over to the left side, and it becomes a negative 3x. Plus y is equal to negative 1. So again, you have to have all of your variable terms on one side, your numbers on the other side. Now I have to, and notice the x's are lined up, the y's are lined up, and the numbers are on the other side of the equals. Okay, so we're going to drop the x's, y's, and equals, and keep the numbers in their signs. So I got 1, negative 5, negative 9, negative 3, 1, and negative 1. Now the size of this matrix, rows by columns, is a 2 by 3. So let's go enter this in. So I'll do second x to negative 1, go to my matrix. That's actually your inverse button. And I'll go over to edit, so I'll right arrow over to edit. And do enter on A. And it's rows by columns, 2 by 3. So I do 2, enter, 3, enter. And then I got 1, enter, negative 5, enter, negative 9, enter, negative 3, enter, 1, enter, and negative 1, enter. Now when I exit out, so I do second mode. I go back in my matrix menu, second x to negative 1, right arrow to math, and I'm going to up arrow to RREF. Press enter on it. Go back in my matrix menu, second x to negative 1, enter on A, enter again. Okay, and what we come up with is this right here. 2 equations, 2 variables. Your first 2 by 2 should be a diagonal of 1, 0, 0, everywhere else. That means RREF worked. That's what RREF means in context of this problem. Now if it worked, then if it didn't work, you'd see something besides this. If it worked, then your far right column is your answers. So this will be x, and this will be y. The order of your answers is the order of your columns. I put x's here, I put y's here. And we'll put parentheses around them. So we got 1, 2 is our answer.